everyone. My name is Tasneem. I'm the senior manager at 98 percentile in the HR department. And today we did it was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be what time would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information. It was extremely great to get associated with them and have a drive at XLR campus. So we are very now coming to the students. What XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th percentile. So today we were here for this IT bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them all the best and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th percentile. We visited XLR for the campus placement drive and it went very well today. Ms. Ambika, Ms. Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. It was a great experience altogether.
Thank you.
Thank you so much.
From entering into this cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 98th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot, and I experienced a lot of things today. So I'm really hope to be placed in that company. I'm confident about that. Thank you.
This was my first association with XLR. I had got a call from Miss Shubha, and we fixed a drive here. Today when we came here, I was not expecting much, but the hospitality was too good. Staff is quite cooperative, and it's like a happy-go-lucky kind of a environment here when it comes to XLR people.
Good morning, everyone. So let us start the session for today. So I'll be highlighting how a data science-based project is done using Python. So we'll start from the part where we have to perform EDA by importing the data set. And I'm going to be also discussing about how you are going to deploy this in Streamlit. Okay. So without any further this one, let me quickly start the session. Okay. So I'll be using Google Colab to run my program. Okay. So I'll be highlighting everything here itself. So the data set that I will be using for the purpose of this project is the Pima Indian Diabetes data set. Okay. So this data set, I'll be taking it up from Kaggle. So I'll just give you a look into how this data set is looking like. So yeah. So this is the data set which is talking about diabetes. So now diabetes in a person can occur because of a variety of reasons. There can be a variety of reasons as to why a person has incurred diabetes, right? So it can also determine the number of pregnancies or the glucose level, blood pressure level, skin thickness, insulin, okay, all this. So it's not imperative for us to learn all these different parameters, but we do understand that all of these different features, they are impacting whether the person is going to have diabetes or not. So ultimately, it is deciding whether a person is going to be suffering from that disease or not. Okay. So based on the age, BMI, insulin, like this, we have to determine the outcome. Okay. We have to determine the outcome of the person. Now, when it comes to building projects like this, we have to first find out what kind of a data set are we dealing with, or what kind of a problem are we dealing with. Are we dealing with a classification problem, or are we dealing with a regression problem? Now, in terms of machine learning, when I discuss about machine learning concepts, or when I say machine learning concepts, we have these two broad categories under machine learning. We have the supervised learning and we have the unsupervised learning. There is also a third category which is called as the reinforcement learning. But this category of machine learning is mostly used in the robotic sector. When it comes to tabular data, we are mostly using supervised or unsupervised techniques. Now, supervised learning means what? We know what we are trying to find. We know what we are trying to find. Say, for example, using the age, insulin levels, the blood pressure levels, etc., etc., I can find out whether a person is going to have diabetes or not. Or you can say that using, suppose, number of bedrooms, number of floors, square foot area, I can find out the price of the house. I can find out the price of the house. So now, when I'm trying to answer this question, whether a person is going to be having diabetes or not, my answer is going to be in yes or no. That means either this person is going to have diabetes or this person is not going to have diabetes. That means my output is going to have only two possible outcomes. What are the two possible outcomes? Either yes or no. Either yes or no. So it can either be from the yes category or it can be from the no category. That means the outcome of this kind of problem is categorical. It is category. That means you are trying to predict the class of the category. You are trying to predict which category the answer is going to come from. Okay. So these kind of problem, they fall under classification. They fall under classification. Now, in the second example, using number of bedrooms, floor, square foot area, we have to determine the price of the house. Now, price, can it be categorical? Do we have price in categories? Price can be anything, right? It can be something like this, 55.7 lakhs or 30.2 lakhs, 99.8 lakhs, or you can say it can be something even like this, 73.2 lakhs. So these are not categories. These are numerical data which do not follow a fixed category or pattern. It can be anything. These numbers, they are continuous in nature. These numbers, they are continuous in nature. So these kind of data, when your outcome is determining this kind of data, we say that the kind of problem that we are dealing with is a regression problem. Okay, it is a regression problem. So the machine learning concepts, you can divide it into supervised, unsupervised, and reinforcement learning. And under supervised learning, we have the classification and the regression based problems. We have the classification and the regression based problems. Now, unsupervised learning means what? We do not know what we are trying to determine. We do not know what needs to be determined. What needs to be determined? That means, suppose I'm giving you something like this: ozone, temperature, wind direction, wind speed, and suppose solar levels. I'm giving you this for information in the form of a table. Now, what are you supposed to do? What should be your outcome? I'm just giving you this data. I'm not telling you anything like using all these three, you need to determine something, or using, you have to, I'm just giving you this data. So when you do not know what needs to be determined, when you do not know what needs to be determined, then we try to look for patterns in the data. We try to look for patterns in the data. And we use these patterns to find out which data points are behaving similarly. Okay, and we categorize them into clusters. So that falls under unsupervised learning. So the problem that we are dealing with is what? Using age, insulin, then blood pressure levels, skin thickness, etc., etc. We need to find out whether the person is going to have diabetes or not. So this outcome variable can be 0, 1, 0, 1, 0, 1, 1, 1, like this. Okay, where 0 indicates what? False. And 1 indicates what? True. So does this person has diabetes? 0 means this particular person do not have diabetes. 1 indicates that this particular person does have diabetes. Okay. So this is the information about the data. So what kind of problem is this, everyone? What kind of problem is this? No answer? So this right here, based on the type of data we are determining in the outcome variable, this is a classification problem. This right here is a classification problem because we need to find out which category it is going to belong to. Okay. Okay, then. Now coming back, so let me open up my Google Colab. And first of all, I need to, since I'm using a cloud-based service to run my program, I need to upload my dataset first. So I will just go here and I will upload my dataset. This is the dataset. I'll be sharing these files once the whole thing is done. Okay. So later on, if you want, you can practice on it. Just give me a minute. So first step first, we will be importing the libraries. So there are different libraries in Python which aids us in fulfilling certain operations. Okay, so we need to import these libraries. So first I will be importing the NumPy library. I'll be importing the pandas library. For visualization purpose, for using graphs and charts, I'll be using the Seaborn. And I will also be importing the Matplotlib library. So these are 4 libraries which I will initially bring into my system. And they are going to allow me to evaluate the different functionalities. Now I need to also import the data set. So what I will do, I will just bring the data set into my programming environment. Now, in order to work on the data set, I need to convert it into a structure which is readable by the program. So this pandas library right here is going to do that job for me. And we are going to get the entire table into a data frame structure. Data frame is nothing, but it is the table which is readable by the program. So how do I read it? Put the data set. So I'll just write df equals to pd dot read underscore CSV. Because it's a CSV file, so I'll be using read underscore CSV, and I will pass in this file. So you can write copy path, or you can simply pass the values here. Control enter, and you have this imported. You can see this green color tick mark. It means that it is successfully imported. Now, once you have imported the data, we do not directly jump into the process of prediction. We have to perform analysis on the data. We have to perform analysis on the data. So this process where you are trying to gather more information about the data, more insights from the data, we call this process as EDA, exploratory data analysis. We call it as what? Exploratory data analysis. Okay, so now we are going to start the process of EDA. Anything that allows us to understand the information about the data, it's going to be giving me the analysis of the data. So this is the thing, exploratory data analysis. So first things first, what do I want to check? I want to have a general idea about the data. So I will write what? df.info. So this info function is going to give me some information about the data frame. Okay. So see, I'm getting what? I'm getting these are the columns which is present in my data frame. And as you can see, it is telling me that this value is of integer type. Glucose is of integer type. Blood pressure integer type. Okay. So I have all of this information. Now, I also want to find out the shape of the data. That means how many rows and how many columns. So that you can also see it in terms of the info column. As you can see, range index is saying you 768 entries. That means you have 768 rows. And you have a total of 9 columns in the data. Okay. So now, if I write df.shape, this is also going to give me the uh, structure of the data. So how many rows and how many columns? 768 rows and 9 columns. Okay. Now, as I can see, the whole of my data frame is having numerical information. That means I can have a statistical summary of my entire data. I can have a statistical summary of my entire data. Anu, Shushmita, are you here? Shushmita, XLR team. You can refer to recordings also, Anu, if you want. You can refer the recordings. Alright. So this is the shape. Now I want what? I want a statistical summary of the data. Okay. So in order to get the statistical summary of the data, I will use the describe function. In order to get the statistical summary of the data, I will use the describe function. Okay. So this right here is going to give me a summary. So see, total number of pregnancy counted row is what? 768. So 768 is pointing to the number of rows or the number of values it has seen in the entire data. So see 768 for everything. What is the mean for the pregnancy column? It is 3.8. What is the standard deviation in the pregnancy column? 3.3. Where is the 25 percentile data? 1. 58% is 3. 75 percentile is 6, and the max is 70. Then glucose is this. These are the information. For blood pressure also, I have this information. So as and when required, I can refer to this describe function to see what is the description of my data. Now I want to see what my data set actually looks like. What does my data set actually looks like? So in order to do that, I'm going to write what? df.head. So the head function is going to give me what? The first 5 rows of my entire data set. It is going to give me the first 5 rows of my entire data set. So control enter, and here you have it. It is giving you the first 5 rows starting from 0. So 0, 1, 2, 3, 4, total of 5 rows. And this is what the top 5 records looks like. Suppose I want to see only the top 3 records. In that case, you can place the number here. So if I say head 3, it means that I want to see only the top 3 records. And you have it like this. This is 1, 2, and 3. Top 3 records. Similar to this, we also have a tail function. So df.tail is going to give me the last 5 rows. By default, it is going to give me the last 5 rows of my entire data frame. So see, this is the last 5 rows of my entire data frame. Now I want to see only the last 2 records, last 2 rows. In that situation, I can write df.tail of 2. And I have this 2. If I only write df, so this is also going to show me the data frame. Okay. So if I only write df, you'll be able to get the output like this. So this is showing me the first 5 records. This is indicating to the last 5 records. And as you can see in the middle, there is this line that is saying dot, dot, dots. Okay. So this indicates that, this right here indicates that there are many more rows in between this last 5 and first 5 rows. Okay. Now, the next thing that I want to check is the correlation between the columns. Correlation means what? Is the glucose column influencing the blood pressure? Is the skin thickness influencing the BMI? Is the diabetes pituitary function influencing the glucose? So this relationship I want to find, is there any direct relationship between the columns? So in order to get that, we have a function called correlation. So df.cor. So df.cor is going to give me the correlation values. So yes, see here. Now I can see these are the different correlation values. And correlation values is going to range between -1 to 1, where -1 indicates strong negative correlation and +1 indicates strong positive correlation. Okay. Now, as you can see, anything which is, if you have a value which is nearer to 0, it means that the correlation is weak. You can say there is no relationship between the data. So in order to get this, I used a core function and it was giving me a table like this. So what is the correlation between glucose and blood pressure? It is 0.15, very weak correlation. What is the relationship between age and pregnancy? It is 0.5, somewhat of a stronger correlation. What is the relationship between insulin and skin thickness? It's a very weak positive correlation, weak positive correlation. Okay, so this is how you can determine. Okay, and any column is always going to correlate with itself. How is glucose related to glucose, or how is age related to age? You'll find that the correlation value is 1, because any column is 100% going to correlate with itself, always. Any column is always going to 100% correlate with itself. Okay. Then the next one is what? You can also, if you want, this whole number thing is not working for you and you want to see it in terms of a graph, then also you can do it. So which two libraries are going to help me with the graph? It is the Seaborn and Matplotlib. So I prefer to use Seaborn more, so I'll be using that. So from Seaborn, sns.heatmap. And I want to plot what? I want to plot this correlation matrix in the form of a heat map. Right, df.core, and I have it like this. So this is a heat map that is generated. So lighter the shade, closer it is to the positive relation, and darker the shade, closer it is towards the 0. Okay, so we do not have a very strong negative relation. So we do not have this minus. Okay, so this is the thing. Now, if you want to display the values alongside these cells, you can simply write N0 equals to true. You can simply write N0 equals to true. N0 equals to true. So control enter. And you'll have the values displayed here along with the cells. So now you have both the values as well as the color coding for the different things. Okay, so this is how you can see your heat map. Now let's see in my entire data set, how many people have diabetes and how many people do not have diabetes. So who is having this information about whether a person is having diabetes or not? It is this outcome column. The outcome column has the information of whether a person is having diabetes or not. So the first person is having an outcome of 1. That means he has diabetes. Second person has 0. That means he do not have diabetes. Again, this person has diabetes, no diabetes, has diabetes. And in the last scenario also, out of the 5 rows, only the second last person has diabetes. So I want to find out from the entire data, how many people has diabetes and how many people do not have diabetes. So what I will do, I'll use something known as value count on the outcome column. So how do I do it? So from here, take the outcome column, the value underscore counts. Outcome. Okay, it's a capital O. So capital O. And this is the outcome. So 0 is what? The person do not have diabetes. So I have 500 people who do not have diabetes, and I have somewhere around 268 people who does have diabetes. Okay, who does have diabetes. Now I have to find out whether there is any kind of, outliers present in the rest of the columns, because this outcome is a categorical data, but whereas the rest of the columns, they are indicating continuous data. So I need to find out whether there is any kind of outliers or not. So in order to do that, in order to see whether they have any kind of outliers or not, I'm going to use which kind of plot? Does anybody remembers? I can use which kind of plot for that purpose? No, it is the box plot. We can use the box plot, correct. So I'll be using a box plot. Okay, so what I will do, I will try to generate a box plot for all the columns. I'll try to generate a box plot for all the columns. So if I want to generate a box plot for all the columns, then I need to do what? I need to first get how many columns I have in my data. So if I write df dot columns, this is going to give me the name of the columns. Okay, name of the columns. I want the number of columns. So I will write len of df dot columns. So I'm getting the value as what? 9. I'm getting the value as 9. So what I will do, I do not want to plot a box plot for the last column. That means I will only keep it as what? -1. Okay, I want to plot it for 8 columns. So I have it 8 and I will store this value as what? I'll store this value as suppose D. D equals to this. And then I'm going to start a loop so that every time the loop runs, it is going to generate me the box plot for every column. So I'll start the loop from 1 and I'm saying that for I in df dot columns. For I in df dot columns. What I want to plot is what? A subplot. So plt dot subplot. Okay, plt dot subplot. And I need to specify for how many rows I want to plot. Because subplot means what? In a single plot, I am plotting multiple things. So first thing that I want to have specify is what? It is the number of rows that I need. So number of rows that I need is total number of values of D. Okay. And in the column, that means at the column part, how many plots do I want? I want only a single plot. And what should be the plot number? The plot numbering should be C. So every time it runs, the C value is going to keep on increasing. Okay. So what should be the title of the plot? Title of the plot should be the name of the column, that is I. And what should I plot? What should I plot? I should plot a box plot. SNS dot box plot. SNS dot box plot df of I for this column values. Okay. And now the next time the loop runs, the C's value is going to be incremented. Okay. Now if I run this, just remember, less than equals to 8, 9. Okay, just give me a minute. Let's increase the size. Here. So this is 0, 5, 40, -1 every minute. Now I have it. So see, I have the box plots for everything now. So see here, what is this? This is the box plot for pregnancy. And I can see what there is outliers. There are three outliers present in the data. For glucose, I have some outlier in the lower end. Okay. Then for blood pressure, I have outliers both in the upper and the lower end. So skin thickness, I have some outliers. For insulin levels also, I have some outliers. Then BMI, yes, outliers are present. Diabetes predictive function has a lot of outliers. Age, yes, outliers are present. Outcome variable is what? We cannot have any, this one. We cannot have any uh, outliers here because it's a categorical data. Okay, because it's a categorical data. So what we can do, we can handle the outliers or we can leave it as it is. We can leave it as it is. Now I want to find out what is the relationship of every column with every other column. So I can use correlation for that, or a plot is useful to find out this relationship. So what is the name of this plot that allows me to find out relationship? What is the name of this plot? We have a scatter plot that gives me scatter plot. Scatter plot allows me to find out the relationship between everything. Okay, so when I want to generate a scatter plot for the entire data set, we can use something known as a pair plot. So SNS dot pair plot. So this pair plot function is going to generate a scatter plot for all possible combinations of my data. So for DF. So it takes a little bit of time. So this is the pair plot. This is the pair plot. And you can try to see who is having some kind of relationship. So if there is a very strong positive correlation, you will see the scatters are moving in an upward direction. If you see a strong negative correlation, it's moving in a downward direction. But what we observe is what? They are not following any kind of specific pattern. The scatters are highly scattered. They are highly random. That means the relationship is very, very weak. Okay. So see, this entire row is representing the insulin on the y-axis. And again, this right here. So what is this? This is the scatter plot between age and pregnancy. What is this? This is a scatter plot between age and glucose. Okay. So this is how you can try to get a scatter plot for the entire data set. Okay. Now, the next is what? We have to check whether we have missing values present or not. Do we have missing values? Do we have missing values? So one way to check for missing value is through the info function. So we did this info function at the very beginning, right? So you can see that it is telling you the non-null count. So here you will be able to determine what is the amount of missing values. So we have a total of 768 rows in the entire data set. And it is telling me what? For the first column, pregnancy, the number of values is what? 768 non-null. 768 non-null means 768 values are present. Okay, if my outcome would have been like this, Just give me a minute. If my outcome would have said something like this, 760 non-null values. If I would have gotten an output like this, 760 non-null, then it means what? 760 values are present and 8 values are missing. 8 values are missing. Okay. So out of 768 rows, we have 768 values for all the columns. So this indicates that I do not have any missing values in this data. We do not have any missing values in this data. So another way of checking the amount of missing values is by using the isNull function. So if I want to find out what is the count of missing values column wise, then I'm going to write what? df dot isAny dot sum. df dot isAny dot sum. So isAny is going to give you the missing values. Sum is going to do what? It is going to count the number of missing values. So see, in our case, what am I getting? 0, 0, 0, 0, 0, 0, like this. That means all of these columns, they do not have any missing values in them. They do not have any missing values in them. You can also do what? So this is what? Count of missing values. You can also find out the percentage of missing values. So same thing, but you'll have to percentage. So how do you get it? You can just get it like this. df dot isAny dot sum. Okay. Wait, I think I made a mistake here. Okay. Whole divided by length of the data frame times 100 times 100. So control enter, and this is going to give you the output in percentages. So currently we don't have any count of missing values. So the outcome is also what? 0%. Okay. So if you want, I will show it to you in a separate file, how this actually looks like. So just to show you how missing values look like, I'll just show it to you using a different data set. Okay. So this is not the main file. So I'll use something, I'll use a data set called Titanic. Let's say I'll read this Titanic data. So df is equals to what? I have to first import the data. So read underscore CSV. It is what? Now if I write df dot isAny, if I write, then see for a Titanic data set, I am having all this. False means what? That the value is not missing. The value is not missing. Value is present. But I cannot do it for the whole data set, right? So what I will write df dot isAny dot sum, so that I have the count of the missing values. Yeah, I think I imported the wrong this one. And there you go. So as you can see, you have number of 86 missing values in age, 327 values in cabin, and 1 missing value in pair. So this is how the count of missing values is going to be displayed. Or you can do what? You can also check the percentages, like how much percent of missing value is missing from this column. So for that, df dot isAny dot sum whole divided by length of the data frame. 100 times 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 times 100. So see, somewhere around 20% of the value is missing from the age column. 78% of the data is missing from the cabin column. Now tell me, is this column useful for me if there is almost 80% of the data missing from this column? If you have a lot of data missing from a specific column, say for example like this, in this cabin column, almost 80% of the data is missing. In that kind of situation, this column is no longer useful for me. This column is no longer useful for me. So you can remove this column. You can remove this kind of columns because they are no longer useful. And how do you remove this column? You can simply write df.drop. So the drop function can remove the columns for you. Okay, drop. Drop what? Drop cabin access equals to 1 and in place equals to true. Okay, now if I try to see df dot columns to check which columns are now present, you'll find that cabin is no longer there. Cabin is no longer there. So this is how we check for the missing values. Okay, this is how we check for the missing values. Now coming back to our main file, we are dealing with the diabetes data, right? Now in this diabetes data, we found that we do not have any kind of missing values present. So which is well and good, we can directly proceed forward. Okay, the next is what? The next is this, that in our data, we can have the problem of scale. We can have the problem of scale. So what is a problem of scale? Problem of scale means this, that see this glucose column, this is having very big values. These are extremely big values. Whereas in comparison, diabetes, the numbers are very, very smaller. These numbers are very, very smaller. So when you have a column with big values such as 500, 1000 like this, and in comparison, you have another column with values like 0.6, 0.7. In that kind of situation, your machine learning algorithm is going to put more weightage to the big values. It is going to put more weightage to the column having the big values. And it is going to put less importance to the columns having smaller values. Although both of these columns are equally important. Both of these columns are equally important. So what we have to do before we proceed, when we observe there is a big change in the magnitude of the values of any columns, we need to perform scaling on the data. We need to perform scaling on the data. So how do I perform scaling? So you can use two techniques. One is the standardization process, or you can use the normalization process. I will be moving forward with the standardization technique because when in your data you have outliers, it is best to do the scaling, feature scaling with the help of standardization. Normalization technique is very, very it is very, very influenced by the outliers. So we are not going to use normalization. We are going to use standardization. Okay. Now standardization is a process which is required in the terms of the machine learning model. So your machine learning model is going to have what? It is going to have certain columns. And using these columns, you are predicting some output. In our case, the output column is what? It is the outcome column. Rest everything, pregnancy, glucose, blood pressure, all of these, they are the independent features. So all the columns that allows you to predict the outcome variable or the target variable, they are known as independent features. So all of these, they are called as independent feature. And this right here, this is called as the dependent feature. Now, before we proceed for scaling, let me divide my data into independent and dependent feature. Independent and dependent feature. Okay. Now, independent feature, I will store it as X. And dependent features, I will store it as Y. So this is what? This is my independent. And this right here is going to be my dependent. So what is the independent feature? How do I write it? So from the data frame DF, take all the columns without the outcome column. So DF dot, I'll just write drop, and I will say that drop the outcome column, and whatever will be the result after dropping it, store it in X. Now this right here is not a permanent drop. So it is just saying that after dropping the outcome column, whatever you are left with, store that information in X. Okay. And what do I want to keep in Y? I want to keep only the outcome column. I only want to keep the outcome column. So control enter. And I have this. Now you can check what are the columns which is stored in X. Or if I write X dot head. So see, I have all the columns except for the outcome column. I do not have the outcome column. Same way I can check for Y also. Y dot head. So see, I have this as the outcome. These are the index numbers. This is the outcome. And what is the name? The name is outcome. Okay. So this is what you have done till now. After this, we need to do feature scaling. We need to do what? Feature scaling on the data. Feature scaling. So for the purpose of feature scaling, I'm going to use standardization. Standardization. Okay. And standardization is the process that uses the concept called Z-scores. Okay. So all the numbers, all these numbers that you see, all these numbers, they are going to be converted into a representation called Z-score representation. So how do you get a Z-score representation? So Z-score representation is what? It is going to, suppose let's take the blood pressure. It is going to take the mean of this blood pressure column, and now it is going to convert all this number into the Z-score. So mean and standard deviation of the blood pressure column. Okay. So what will it do? Suppose this is 72. So 72 minus mean divided by the standard deviation. So whatever you get, that is going to be the Z-score. Z-score for this one. This is going to be the Z-score for this one. Suppose I want to see what is the mean and standard deviation of blood pressure. So how will I do it? DF of blood. Let me take the glucose. Blood pressure is a big name. So I'll take glucose dot describe. So see, what is the mean of the glucose? 120.89. What is the standard deviation? 31.97. Okay. So what I will do, I'll take the mean of the glucose column. Just write mg is what? DF of glucose dot mean. And here I am going to see what? Standard deviation. standard deviation. So GF of glucose dot STD. So now I have the mg and sg. Suppose I want to find out the z-score value for this number 148. So what will be the z-score value? So z-score will be like this. 148 minus mean, which is mg, whole divided by standard deviation, which is sg. So see, it is coming to be somewhere around 0.84. So like this, we have to do it for the whole data. Okay. So in order to do that, what I will use is, I will use the feature scaling called standardization. So in order to use this direct function, I have to call upon that, I have to import that library. So sklearn.preprocessing import the standard scaler. Okay, so I have imported it. After importing, I'm going to initialize the standard scaler. Okay, so I'll just write what sc is equals to standard scaler. Standard scaler. After initializing, I have to now apply it to the data. I have to now apply it to the data. So, which data do I want to apply it on? I want to apply it in X. I want to apply it in X because the standardization should be done for all of my columns because every single column needs to be converted into their z-score representation. Okay, so we have to convert everything into their corresponding z-score representations. So for that purpose, first thing that we have done is imported the standard scaler. Importing means you are going to use it now. But in order to use it, you have to first initialize it. So we are going to now initialize the standard scaler and now we have to apply it to the data. We have to now apply it to the data. So I'll just write what? Scale X is equals to what? Sc dot fit underscore transform sc dot fit underscore transform on what? On the set of X variables. Okay. So control enter and I have this. Now if I try to see the scaled, now if I try to see the scaled X, I'll see this. All these are the different values. All these are the different values. So see, we obtained this one, right? 0.84 for which value? 148 in terms of glucose. So glucose is the second column and I'm getting 148 here, right? 148. So what was the corresponding z-score value? 0.847. So if you see here, first is the pregnancy, second one is what? 0.84. So you might not get the exact value, but see, this is the thing, 0.84. Okay, so this is how the rescaling is done. This is how the entire rescaling is done. Okay. So after this rescaled values, we are now going to proceed towards the machine learning model building. Okay, machine learning model building. So that we are going to do it tomorrow. Okay, that we are going to do it tomorrow. All right then. I hope you were able to follow the session till here. Just rename this. so that later on it will be easier for me to share this file with. Okay. All right then. Any questions for me here? Where did I drop the outcome column? I did not drop the outcome column. I'm simply separating my data into the two features, independent and dependent features. So this X is like what? X are the set of columns which is going to influence Y. That is the outcome. Okay, I'm separated the independent and dependent features. So outcome is not my independent feature, right? It's a dependent feature. Dependent implies what? It is dependent on a variety of other factors. Okay, so that's why the dependent I'm storing it in Y and the rest everything I'm storing it in X. Is this clear, Anadhir?
Thank you, ma'am. We'll continue tomorrow. So thank
Okay.
you, students. Thank you all.
Okay.